Good morning, everyone. I'm Yamuna S., Assistant Professor from the Department of ECE. Today, I'm excited to present to you on the topic of prototyping and iteration. In this session, we'll explore the key concepts, processes, and best practices involved in developing effective prototypes through iterative cycles. So, let's get started and dive into this fascinating subject. Let's talk about prototyping and why it's so crucial in the entrepreneurial process. Prototyping allows us to turn our ideas into tangible forms, helping us test and refine concepts early on. This step is essential because it reduces risk and saves time and resources down the line. There are different types of prototypes, ranging from simple sketches to fully functioning models. The type you choose depends on your goals and the stage of development you're in. For example, a quick paper prototype might be perfect for initial feedback, while a more advanced prototype can be used for detailed testing. We also have a variety of methods and tools to create prototypes. These include traditional techniques like hand drawing or foam models, as well as advanced tools such as 3D printing, electronics, and software platforms. Each method offers unique advantages and can be chosen based on the specific needs of your project. In our hands-on sessions, you'll get to experiment with some of these tools, like 3D printing, working with electronics and software development. The goal is to develop a prototype based on the opportunities we've identified earlier. And remember, prototyping isn't just a one-and-done process. It's iterative. After creating your prototype, you'll gather feedback, analyze it, and make improvements. This cycle of testing and refining is key to developing a successful product or service. Ultimately, prototyping and iteration are about learning quickly, adapting continuously, and moving closer to a solution that truly meets market needs. Prototyping in the entrepreneurial process is a crucial step that helps bring ideas to life. When we talk about prototyping, we're referring to the process of creating an early model or version of a product. This isn't about building the final product right away, but rather about testing and refining. The main goals here are to evaluate the functionality, which means making sure the product works as intended. We also look at the design, ensuring it's appealing and user-friendly. And finally, usability is key, making sure that people can easily interact with and benefit from the product. By focusing on these aspects early on, entrepreneurs can identify issues, gather feedback, and improve their ideas. This iterative process ultimately helps save time and resources, and it aligns perfectly with the overall goal of developing innovative market-ready solutions. Now, let's talk about the importance of concept validation in the entrepreneurial process. First, there's the feasibility check. This step is all about confirming that your idea can actually be practically implemented. It's about asking, is this realistic? And making sure you can turn your concept into reality without insurmountable obstacles. Next, we have real-world testing. This is where you put your idea into actual scenarios to see how it performs. Testing in real life helps you identify potential challenges early on, things you might not have thought of just by theorizing. It allows you to gather valuable feedback and make improvements before scaling up. Both these steps are critical because they help ensure that your idea isn't just good on paper, but also viable and ready for the market. They reinforce the overall theme that validation is a key part of turning an entrepreneurial vision into a successful venture. Let's talk about user feedback. Understanding user needs is crucial because it provides us with valuable insights into what our users actually want and where they might be facing challenges. By listening to their feedback, we can identify pain points that may not be immediately obvious but are essential to address. This understanding helps us tailor our product more effectively. It ensures that we're not just building something based on assumptions, but rather on real, actionable insights. Now, connecting this to market alignment, it's all about making sure our product meets the expectations of our target market. If we understand what users need and want, we can design and refine our offerings to fit perfectly into the market landscape. In essence, user feedback guides us to create solutions that resonate with our audience and stand out in the marketplace. It's a vital part of ensuring our product's success and relevance. Let's talk about risk reduction, which is a crucial part of any successful project. First, we have early flaw detection. This means identifying issues early in the process, which allows us to address them before they become bigger problems. Catching problems early is not only more efficient, but also much more cost-effective. Next, we want to focus on minimizing errors. By catching and resolving issues early, we can avoid costly mistakes during production or after the product has launched. This proactive approach helps ensure that our project stays on track and within budget, ultimately leading to a better outcome. Together, these strategies emphasize the importance of early intervention and careful quality control, which are key to reducing risks and ensuring the success of our overall efforts. All right, let's talk about resource optimization. One of the key aspects here is focusing on viable ideas. What does that mean? Well, it's about filtering out ideas that aren't practical or achievable so that we don't waste our valuable resources, whether that's time, money, or effort, on things that aren't going to succeed. By doing this, we ensure that every resource we invest is directed toward ideas that have real potential. This approach keeps us efficient and helps us make smarter decisions, aligning perfectly with our overall goal of maximizing impact while minimizing waste. Remember, focusing on viable ideas isn't just about being selective. It's about being strategic to get the best results from what we have. When we talk about efficient allocation, we're really focusing on how to use our time, resources, and budget in the smartest way possible. This helps us avoid wasting effort on ideas that haven't been proven to work yet. By doing this, we make sure every dollar and every minute we invest is moving us closer to our goals. Now, having a tangible representation, like a validated prototype, makes a big difference. It's one thing to talk about an idea, but when you have something concrete to show, it becomes much easier to communicate your vision to investors. It turns abstract concepts into something real they can see and understand. And building trust is crucial. Showing that you're prepared and have a solid prototype demonstrates that you're serious and ready to move forward. This increases your chances of securing funding because investors want to see that you've done your homework and that your ideas are viable. So, in the context of our overall presentation, these points highlight how smart planning and proof of concept are key to turning ideas into successful realities. Let's talk about faster iteration and why it's so important. When we focus on rapid improvements, it means we can make quick changes based on feedback. This agility allows us to adapt swiftly to market needs and stay ahead of the competition. Additionally, continuous product evolution is key. By constantly refining our offerings, we ensure that our product not only meets user demands, but also remains competitive in a rapidly changing environment. Together, these approaches help us stay flexible, responsive, and always aligned with what our users and the market require. This is a crucial part of maintaining our innovation and staying relevant in our industry. Let's take a closer look at the different types of prototypes. When we talk about prototypes, we're referring to various ways to bring our ideas to life and test them out. Each type serves a specific purpose in the design process. First, we have the low-fidelity prototypes. These are usually simple, quick, and inexpensive. Think of paper sketches or basic wireframes. They help us explore concepts early on without investing too much time or resources. Next are the high-fidelity prototypes. These are more detailed and closer to the final product. They often look and feel very real, allowing us to test not just the design, but also interactions and user experience. Then there are functional prototypes. These prototypes focus on the functionality and technical aspects. They might be partially or fully operational, helping us evaluate how the system works in real-world scenarios. Understanding these different types is crucial, because choosing the right one depends on what stage we're at in development and what questions we need to answer. It's all about using the appropriate level of detail to inform our decisions and improve the final product. This ties back to our overarching theme of iterative design, using prototypes to learn, refine, and innovate effectively. Now, let's talk about low-fidelity prototypes. These are characterized by being simple and inexpensive, often made with materials like paper, sketches, or wireframes. The main goal here is to quickly communicate ideas and gather early feedback without investing a lot of time or resources. For tools, you can use basic pen and paper, sticky notes, or even digital wireframing tools, whatever helps you visualize your concepts easily. These prototypes are especially useful during brainstorming sessions and the early stages of design, where flexibility and speed are key. They're also great for discussing ideas with team members or stakeholders early on, to ensure everyone is aligned before moving forward. Overall, low-fidelity prototypes serve as a fast, cost-effective way to explore concepts, refine ideas, and get valuable input early in the design process. Let's talk about high-fidelity prototypes. These are detailed and polished models that closely resemble the final product. They are interactive, allowing stakeholders to get a real feel for how the finished design will work. The main purpose of these prototypes is to validate our design and usability, making sure everything functions as intended, while also gathering feedback on both the appearance and the functionality. To create these high-fidelity prototypes, we have a variety of powerful tools at our disposal, including Adobe XD, Figma, Sketch, Unity, React, and even 3D printing for physical models. These tools help us craft realistic and functional representations of our ideas. In terms of applications, high-fidelity prototypes are invaluable for usability testing. They let us observe how users interact with our design and identify any issues early on. They are also great for presentations to investors, helping us communicate the value and potential of our project in a compelling way. Overall, high-fidelity prototypes are a crucial step in turning our concepts into tangible, testable, and convincing representations of the final product. Let's talk about the proof of concept, or POC. When we focus on a POC, the main goal is to demonstrate technical feasibility. It's less about how it looks and more about whether it can work from a technical standpoint. The idea is to quickly test whether our concepts are viable without getting bogged down by aesthetics. The primary purpose here is to validate that our approach can actually be implemented and to identify any potential risks early on. This helps us make informed decisions moving forward. To do this, we typically use various tools like programming environments, hardware setups, and rapid prototyping platforms. These tools allow us to build and test ideas quickly and efficiently. You'll often see POCs in research and development, or R&D, and in technology-driven innovation projects. They're essential for exploring new ideas and pushing the boundaries of what's possible before investing heavily in full-scale development. So, in essence, a POC is about proving that our ideas are technically feasible and manageable, paving the way for more detailed development down the line. Now, let's talk about mockups. These are static visual representations that focus primarily on the design and layout of a project. They help us visualize how the final product will look, giving us a clear picture of the visual elements in place. The main purpose of mockups is to finalize the design and present these visuals for feedback, ensuring everyone is aligned before moving forward. When creating mockups, we typically use tools like Photoshop, Illustrator, or Figma, which allow us to craft detailed and realistic images. These mockups have a wide range of applications, including product design, marketing materials, and obtaining design approval from stakeholders. Overall, mockups are a crucial step in the design process because they provide a tangible visual that helps communicate ideas effectively and gather valuable input. Let's talk about functional prototypes. Their main purpose is to validate usability and functionality, helping us identify any workflow or interaction issues early on. These prototypes are essentially working models that demonstrate the key features, operations, and core interactions of our design. They allow us to see how everything works in practice, which is crucial for refining the user experience. In terms of tools, we often use Axure and InVision for creating these prototypes, along with web development tools. For more hardware-focused prototypes, platforms like Arduino and Raspberry Pi come into play. These tools give us the flexibility to develop prototypes that are as close to the final product as possible. As for applications, functional prototypes are invaluable for usability testing, allowing us to gather user feedback and make improvements. They're also great for investor demos, helping stakeholders understand the product's potential in a tangible way. Overall, they're an essential step in transforming our ideas into practical, testable solutions that guide the development process. Let's talk about paper-based prototyping first. This method involves creating sketches, wireframes, and storyboards on paper. It's a very accessible way to visualize ideas early on. One of the main advantages is that it's low cost, so you can experiment freely without breaking the bank. It also allows for quick iteration, meaning you can make changes rapidly and see what works best. Plus, it encourages team collaboration, as everyone can contribute and give input easily. This approach is especially useful in the early stages of UI and UX design, helping teams map out user interaction flows before moving to more detailed prototypes. Now, shifting gears to digital prototyping. This method uses specialized software like Figma or Adobe XD to create interactive prototypes. The biggest advantage here is that digital prototypes are much closer to the final product in look and feel. They allow for user testing and feedback, which is crucial for refining the design based on real user interactions. Digital prototyping is ideal for developing software, mobile apps, and websites, where interactivity and real-world functionality are key. By using these tools, designers can simulate how users will interact with the product, making it easier to identify issues early and ensure a smoother user experience. Now, let's take a look at physical prototyping. This method involves creating tangible models, often through techniques like 3D printing, to test both the design and the function of a product. The main advantage here is that it allows for hands-on testing, which is invaluable for assessing ergonomics and durability firsthand. This approach is particularly useful in fields like industrial design, hardware products, and architecture, where physical interaction helps refine the final outcome. Moving on, another key method is role-playing. This involves simulating user interactions to better understand the user experience and the flow of a system. It's a powerful way to gain human-centered insights and to uncover emotional responses that might not be obvious through other testing methods. Role-playing is especially relevant in service design, customer experience, and system workflows, where understanding the user's perspective can lead to more intuitive and engaging solutions. Together, these methods emphasize the importance of experiential testing, whether through physical models or simulated interactions, to create products and services that truly meet user needs. Let's take a closer look at the Wizard of Oz prototyping method. Essentially, this involves creating a prototype that appears to be fully automated, but behind the scenes, it's actually operated manually. This allows us to simulate complex systems without the need for complete development up front. It's particularly useful when testing things like voice assistants, chatbots, or other AI applications where the user experience can be refined before building the full system. Moving on, we also have rapid prototyping, which is all about speed and flexibility. This approach uses tools like CAD, 3D printing, and electronics to quickly iterate on designs. The main advantage here is that it accelerates innovation and allows for continuous improvements, helping teams learn and adapt faster. Both of these methods play a crucial role in modern product development, enabling us to test ideas efficiently and refine our solutions before investing heavily in full-scale development. They help us stay agile and responsive to user needs and technological advancements, which is key to staying competitive in today's fast-paced environment. Now, let's take a closer look at 3D printing. When it comes to tools, some of the most popular ones include MakerBot, Ultimaker, and Formlabs. These devices allow us to create physical models quickly and accurately. The main applications are hardware testing and design validation, which means we can quickly turn digital concepts into tangible prototypes. The biggest advantage here is the ability to iterate rapidly, making adjustments and refining designs with speed and ease. Moving on to electronics prototyping, we have tools like Arduino, Raspberry Pi, breadboards, and sensors. These are essential for developing functional systems and Internet of Things devices. By creating and testing electronic circuits, we can ensure they work well in real-world conditions. This approach helps us validate our ideas early, saving time and resources as we bring new electronic solutions to life. Both of these methods, 3D printing and electronics prototyping, highlight the importance of rapid iteration and hands-on testing. They are crucial parts of our overall innovation strategy, enabling us to move from concept to reality faster and more effectively. Now, let's talk about software prototyping. When it comes to tools, some of the most popular options include Figma, InVision, Axure, and Adobe XD. These platforms are incredibly powerful for creating interactive wireframes and designing user interfaces. The main advantage here is that you can refine your software interfaces early in the process, before diving into actual development. This helps identify issues and improve user experience, saving time and resources down the line. Switching gears, we also have laser cutting, which involves tools like Glowforge and Epilog. These are perfect for creating precise cutouts and engravings. The real strength of laser cutting is that it allows us to produce highly accurate prototypes, especially when intricate designs are needed. This technology complements software prototyping by turning digital ideas into tangible, detailed models that can be tested and refined physically. Both approaches, software prototyping and laser cutting, are about iterating efficiently and ensuring that the final product really meets user needs and design intent. They're essential tools in the modern development process, helping us bridge the gap between concept and reality. Let's talk about simulation tools, which are essential in modern design and testing processes. Here, we have some key tools like MATLAB, Simulink, and ANSYS. These platforms enable us to create detailed virtual models of our systems and components. The main application of these tools is virtual testing and design validation, allowing us to evaluate how a design will perform under real-world conditions without building physical prototypes. This is a huge advantage because it saves both time and costs. Instead of manufacturing multiple prototypes, we can simulate and refine designs digitally, leading to more efficient development cycles. Overall, these simulation tools are vital for innovating faster and reducing risks in our projects. Let's take a closer look at some hands-on prototyping activities that are essential in our development process. First, 3D printing. This involves designing our models using CAD software, then printing them out to create physical prototypes. Once printed, we can test these models in real-world conditions, making adjustments as needed. It's a fantastic way to quickly bring our ideas into the physical realm and see how they perform. Next, we have electronics prototyping. Here, the focus is on assembling circuits, programming them, and testing for functionality. This step allows us to verify that our electronic components work together seamlessly and meet our design requirements before moving to mass production. It's a critical phase to catch issues early. Finally, software prototyping. This involves creating interactive software versions of our ideas. These prototypes let us gather valuable feedback from users or stakeholders, which helps us refine the user experience and functionality. Iterative testing and refinement in this stage ensure that the final software aligns closely with user needs. Overall, these hands-on activities, 3D printing, electronics, and software prototyping, are about bringing our concepts to life, testing them, and improving them through real-world interaction. They are vital steps that connect our initial ideas with functional, reliable final products. Let's talk about developing prototypes based on opportunities. First, it's crucial to identify the opportunity. This means doing thorough research, clearly defining our goals, and really understanding what users need. By doing this, we ensure we're creating solutions that are relevant and valuable. Next, we need to select the right prototyping method. The choice depends on where we are in the development process and the resources we have available. For example, early on, we might opt for quick, low-fidelity prototypes, while later more detailed models might be appropriate. Then, we move on to building the prototype itself. This involves developing it with suitable tools and, importantly, collaborating with experts who can bring their skills and insights to the table. This teamwork helps us create more refined and effective prototypes. And lastly, always keep the user's needs front and center. We should test the prototype, gather feedback, and then iterate and refine it based on what we learn. This ongoing process ensures the final product truly resonates with users and meets their expectations. Remember, developing prototypes is about turning opportunities into tangible, user-centered solutions. Alright, so now that we've developed our initial prototype, the next crucial step is to gather feedback. This means talking to both users and stakeholders to understand how they perceive the design and whether it meets their needs. Listening carefully to their input helps us identify what's working and what isn't. Once we have that feedback, we need to analyze it thoroughly. This isn't just about collecting comments, it's about understanding the underlying issues or suggestions, and then refining our prototype accordingly. Think of it as fine-tuning a musical instrument. Each iteration brings us closer to the perfect harmony between user needs and our project goals. And this process isn't a one-and-done deal. It's iterative, meaning we repeat these steps, gather feedback, analyze, refine multiple times. Each cycle helps us improve the prototype, making it more aligned with what users want and what the project aims to achieve. This continuous loop ensures we don't just settle for a good idea. We keep improving until our prototype truly meets user needs and fulfills our project objectives. It's a key part of creating effective, user-centered solutions that stand the test of real-world use. All right, now let's talk about analyzing feedback. When we look at the feedback we've gathered, the first step is pattern identification. This means we want to look for recurring themes or issues that keep popping up. These patterns give us valuable insights into what's really affecting our users or customers. Next comes prioritization. Once we spot these common themes, we need to decide which ones to tackle first. Focus on the issues that will have the biggest impact or are most urgent. Then, we move to actionable feedback. This is where we identify specific suggestions we can implement, like improving navigation or streamlining the checkout process. Clear, concrete actions help us make real improvements. On the flip side, not all feedback is useful. Non-actionable feedback might be irrelevant or too vague to act upon. Things like general complaints without details or comments that don't relate directly to the product or service. To do all this effectively, we use tools like spreadsheets to organize data, heat maps to visualize user behavior, and feedback software to gather and analyze comments. These tools help us see the bigger picture clearly and make informed decisions. By thoroughly analyzing feedback this way, we can continually improve and better meet our users' needs, keeping our overall goals in focus. Now, let's talk about refining the prototype. First, we need a systematic roadmap for modifications. This means planning out each change carefully, ensuring we're making improvements in a logical order. Next, usability and functionality are key, so we'll focus on improving navigation to make it more intuitive and adding features that users actually want and need. We also follow an iterative testing approach, meaning we'll test after each change to verify that we're meeting user needs and catching any issues early on. Collaboration is essential here. We'll involve design, development, and testing teams throughout the process. By working together closely, we ensure that all perspectives are considered, leading to a more refined and user-centered prototype. This cycle of planning, improving, testing, and collaborating helps us create a product that truly aligns with our goals and user expectations. All right, let's talk about the next phase, repeat the process. This is all about continuous iteration. Essentially, we keep cycling through development, testing, and refining until the prototype actually meets our set standards. It's not a one-and-done deal, it's about persistent improvement. Then, we move into validation. Here, the key is making sure that the changes we've made actually solve the issues we identified earlier. It's also important that these adjustments align with our overall goals. We want to ensure that every tweak gets us closer to the ideal solution. Finally, measuring progress is crucial. We need to track our improvements over time and document what we learn along the way. This helps us understand what works, what doesn't, and guides us in making smarter decisions for the next iteration. All of this ties back to the core theme of continuous improvement, constantly refining until we achieve the best possible outcome. Now, let's take a look at the benefits of feedback and iteration. First, when we focus on user-centric design, we're making sure that our product truly meets user expectations. This means listening to their needs and adjusting accordingly, which ultimately leads to a better user experience. Next, improved quality is a major benefit. By continuously refining our work through feedback, we enhance both functionality and usability, making the product more reliable and easier to use for our end users. Risk mitigation is also critical. Regular feedback loops help us catch potential issues early on, reducing the chances of costly errors down the line. This proactive approach keeps the project on track and within budget. Finally, stakeholder alignment is key. By involving stakeholders throughout the process, we ensure that everyone's goals and expectations are aligned, making sure that the final product meets the broader business objectives. All these benefits connect to the overall theme of the presentation, showing how iterative development and feedback are essential for creating successful, user-focused solutions. Thank you so much for your attention today. I really appreciate your time and engagement throughout this presentation. Remember, the key points we've discussed highlight the importance of innovation, collaboration, and continuous improvement. These are the elements that drive success and growth in any organization. I hope you leave here inspired to apply these concepts in your own work. Once again, thank you for being part of this journey. I look forward to seeing how you will implement these ideas moving forward.